We do Part B, operations with complex numbers. Simplify the complex expressions using order of operation and powers of I. So as a reminder, for powers of I, it is based on a loop of 4. That is I to the power of 1, I to the power of 2, I to the power of 3, and then I to the power of 4. After that, anything's going to repeat over based upon that circle of 4. So I would also continue I5, 6, 7, 8, and then 9, 10, 11, but they're going to repeat the same 4 values. So those 4 values are going to be in rounds of a pattern called I1, I1. So we're going to write I1, I1. Then we're going to know that it goes from positive to negative to negative to positive. Now that's your shortcut pattern. We did spend time in class going over the will of I's and expanding them and rewriting them, but these are the 4 that you need to memorize. So when you have a problem like number 1 that says I40 and your directions say to simplify, that is not in proper form. Your proper form needs to be one of these 4, the I, the -1, the negative I, or the 1. So there's different ways to do this. You can figure out where that 40 is going to be placed by counting. So you could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 20, 24, 28, and you can keep going to see where you're going to get to 40. Or you can use what we call the remainder pattern. So we're going to take that exponent, 40, and we're going to divide it by 4 because our numbers repeat on a loop of 4. So 40 divided by 4 is a perfect number, 10, because 10 times 4 is 40. And because it's perfect, that means we have a remainder of 0. So there's 2 ways to think about this problem when that happens. The first one is you can think of it as equivalent to I to the power of 0. And anything to the power of 0, what we were taught a long, long time ago, is the whole number 1. If that part does not make sense to you, then you can think to yourself, well, if it's the perfect multiple of 4, it's going to take me 10 rounds to get to that 40. And when I land there, I'm going to land perfectly in this spot since it's a multiple of 4. And so that means it is equivalent to the number 1. So different ways to think about it. You just try to figure out the one that makes the most sense to you. So I'm just going to make up another number. It's not on our reteach here, but just to kind of help you out a little bit. Let's say that you had something I to the power of 34. So you would need to do 34 divided by 4. And you can use your calculator a little bit, not too much. It doesn't give you the actual remainder. So you can see that it's not perfectly divisible by 4. And so when I do 34 divided by 4, I get 8 because 8 times 4 is 32, and I would have 2 as my remainder. So that means I to the 34th power is the same as I to the power of 2 because of that remainder. And then I to the power of 2 would be -1. So please practice that remainder portion to help you get ready for those proper forms. All right, next problem number 2. You have some square roots with negatives, and we learned that when you have a negative square root, that is where the I comes about. All right, so what we're going to do, I'm going to zoom in just a little bit so you can see this problem a little bit better. We're going to separate out that square root of -1 from the square root of 20 because we learned that the square root of -1 becomes an I, and we need to simplify that square root of 20. If we type that in, you can see it's not a perfect square root, so you're going to have to break that down either using your ladder method, your birthday cake method, or your factor tree. I'm going to use my factor tree to help us out. Now, there are different ways to do this, but remember, you're trying to get to your primes. So I have a 2, 2, and a 5. And so when I rewrite that square root of 20, it's going to be equivalent to 2 times 2 times 5, and you can always type that in to make sure you did your factor tree correctly, or your birthday cake, or your ladder. And then you look for your groups of 2, because square root is related to squaring a number. 2 times 2 would break out of the group as a 2. Remember, we talked about the long way that 2 times 2 is technically 4, and the square root of 4 is that perfect number 2. And so they're no longer under that radical, and you're only left with that 5 on the inside. So when we write this negative 20 with that I, your 2 will go in front of the I, and your root 5 will go behind it. So this 2 root 5, 2I root 5, replaces the square root of negative 20, and then we need to simplify that right side. So we have that negative and that 25, so pretty much the same thing as before. Let's split it up into the square root of negative 1 and the square root of 25. We know that the square root of negative 1 is I. We also know that the square root of 25 is a perfect number 5. So then we get a 5I. That 5I replaces the square root, but we need to make sure that we do not leave behind that times by 4. So I'm just going to drop down a parentheses to make sure I don't lose the place of where that 4 is actually supposed to belong. So from there, I have 2I square root of 5 times 4 times 5I. So we follow our PEMDAS and do our order of operations. Let's take that negative 4 to those that times 4 to those parentheses, and we're going to get a 20I that needs to be multiplied by that 2I root 5. Reminder about multiplication with roots. You can only do a root times another root. So because we do not have another square root of 5, that's going to stay. And we're simply going to multiply our coefficients 2I times 20I. Well, 2 times 20 is 40. And then I times I becomes I squared. So I squared is on our list to simplify. From our powers of I, we know that I squared is the same as negative 1. And my final proper form will be negative 40 root 5. Next one over, number 3, we have negative 7I plus 6 minus 5I minus 4I. So again, order of operations here, we have adding and subtracting. And then we just need to make sure to be careful about distributing with that subtraction. So this becomes a negative 4I. There is technically a 1 there for us to distribute, but we don't normally show that because when we multiply by 1, it stays the same. And so those parentheses will just drop. And same for that 1 here. And multiplying, again, those parentheses will just drop. And I need to drop down that positive 6 sign. So after we do that, we need to combine our like terms. We need to also remind ourselves that the real number needs to go in front, and all those imaginary numbers will move to the back. And so we have negative 7 minus 5 minus 4. That gives us a negative 16I. All of our answers need to be in that form, A plus BI, where we want the real in front and that imaginary or complex located in the back. And then the last one we have parentheses touching. So again, more PEMDAS, but we're definitely going to distribute first. So 4 times 10, and then 4 times I. And then our negative 2I times 10, and our negative 2I times I. That I squared again is on our powers of I. So I squared is negative 1. We're going to need to put that into proper form. And that negative 1 is being multiplied by that coefficient of negative 2. So negative times negative becomes positive. So this is now rewritten. And we have 2 real numbers that we need to combine. So remember, real plus real. 40 plus 2 must go in the front. And then our imaginaries, 4 minus 20, combine, and they must be placed in the back. So please just always make sure that you use your powers of I for your simplest form, And then make sure when you have a binomial with a real and a complex portion that you put those into proper form as well.